Welcome back to another extravaganza. We're living life on the edge here. And what I'm going to do in this animated mind map is I'm going to look at the how resistance is related to length. So what we're going to look at is R is directly proportional to length. What does that mean? Well, if you increase the length, you increase the resistance. If you decrease the length, you decrease the resistance. To be even more accurate, if you double the length, you double the resistance. If you halve the length, you halve the resistance. If you quarter the length, you quarter the resistance. That is exactly what directly proportional means. So the resistance, let's get down to the nitty gritty. The resistance is proportional to the length. So R, there's the proportional sign, is length. So keep it simple, stupid. As R gets bigger, L gets bigger. And vice versa. As L gets bigger, R gets bigger. If L gets smaller, what can you say? R gets smaller. To be more specific, we could say as L doubles, R doubles. As L halves, R halves. Fair enough? So what we're saying here is that resistance is proportional to length. How do you go a stage further than that? Resistance is equal to a constant times the length. So what we're saying is R is equal to K times L. Now for those saddos amongst you who's thinking of doing A-level physics, this is important in A-level physics. This K is known as the resistivity. We don't have to know it, but sometimes it's great to just have a wee look up into the next level. And you don't have to know that at GCSE, but you would have to know it at A-level. So it just talks about the properties of material and its resistance. So what I want you to do in this animated mind map is I want you to page 459, and this, no, it's not page 459. Sorry, it's not 459. It's page 466. Page 466. And it's resistance and length. Right? So it's resistance and length. So what I want you to do is I'm going to talk you through the practical. I'm going to discuss the diagram and the setup. I'm then going to give you a set of data. I'm then going to explain what you want to find out. Then I want you to write up the practical on page 466. I want you to do the table that's on this animated mind map. I want you to draw the graph, and then I want you to give the conclusions, and finally, guess what? I want you to hand it up. So I'm going to draw, hold on just so you can get rid of that undo there. No. Sometimes you're too particular. Right, so I'm going to draw the circuit. There's the anode, there's the cathode. So again, if you've drawn the other two, you'll find that this one's very similar to the last one. Coming down here again. And I'm going to draw this in a different colour because I'm high tech today. There's the wire. Then go back to black. And round to the cathode. And there's my ammeter. And because we're high tech, this here is going to allow me to measure the voltage and to change the length. There's the length. So this sort of loop, this here is called a jockey here. And this jockey can slide along this wire and change the length of the conductor. So that's what it does. Measures the voltage across it. So quick meander through this There's your anode. There's your anode. There's your switch. Oh, switch is not showing. There's the switch. Close the switch, complete the circuit, comes down. The ammeter is going to give you the current. This is going to give you the voltage for that length. So we know the current, we know the voltage, we're going to be able to find the resistance using Ohm's law. The backup around to the cathode. Fair enough? Now I'm going to draw the table. Again, tables are very important. If you don't draw a table properly, you won't get the marks. So I'm going to put these values in, and again, up to you when you're writing up the practical to use this table to draw the graph. So the voltage is measured in volts, the current is measured in amperes, the resistance is measured in ohms, and the length is measured in meters. Well, it's supposed to be length there, and that's supposed to be ohms. You see? Oh well. Now I'm going to put a set of values in. 0.1, 0.2, 0.3, 0.4 and 0.5. Now, see that column there? I'm going to leave that blank, you're going to have to fill that in. But here's the voltages that I used. Right? And just to make sure we get them all in line, just put a bar under each one of them. In the real world you could just use the line of the page, but in the virtual world it's a bit different. So here are the currents that I measured: 0, 0.5, 1.0, 0.83, 0.88, and 0.9. Now you can work out the values of R there. Fair enough. How do you work that out? R equals V over I. V is measured in volts. Do we have volts over here? Yes. The current is measured in amperes. Do we have amperes up here? Yes. And finally, the resistance is measured in ohms. Do we have ohms up there? Yes. So you work out the table. You fill that, see that table there? You fill that in using that formula. Then finally, you're going to draw a graph of V against length. V measured in volts against length measured in meters. You should find it a straight line graph through the origin. We know that the voltage is proportional to the length, so the voltage is equal to the constant times the length, and the constant is that gradient that's supposed to go through the origin. In my world it is. So what I want you to do, I want you to write up this practical. It's on page 466, 467. I want you to draw the table. There's the table over here. That's the table of data I want you to use. I want you to plot the graph. There's the graph. Look, follow the blue spot. You see there's the graph. I want you to, the conclusions in the page 467. Then I want you to upload it and submit it to me within the time that I allow you, and I will record this and I will use the mark for whatever we have to use it for. So this is a quick one, so see you shortly. Toodle bip.